The topic is all about fluid dynamics. What is fluid? Fluid is a substance, as a liquid or gas, that is capable of flowing and that changes its shape at a steady rate when acted upon by a force. The sum of the most fundamental concepts of fluid properties are temperature, density, and also composition, which is according to sciencedirect.com. In addition, the atoms in a liquid are free to move around, although they cannot move closer together or farther apart. From dkfindout.com. Example 14.1, page 693 to 694. What force must a dam withstand? Consider the pressure and force acting on the dam retaining a reservoir of water. Suppose the dam is 500 meters wide and the water is 80 meters deep at the dam as illustrated below. Letter A, what is the average pressure on the dam due to the water? Letter B, calculate the force exerted against the dam. So this is our illustration. Ang average pressure kuno sa weight sa tubig mao ang pressure at the average depth, which is H equals 40 meters. Since ang pressure nag-increase linearly with the depth, the force exerted to the dam by the water mao ang average pressure times the area of a contact. So let's proceed to solution. Letter A. Mao ni ang formula to find the average pressure due to the weight of a fluid. So ato lang i-substitute ilahang value. H is equals to 40 meters. P is our density. From table 14.1 mo ni siya ang naa-adto. Then ato na siya i-plug in dire. So mo ni siya. Then ang G is our acceleration due to gravity, which is 9.8 meter per second square. Then we obtain 392 kilopascal. This is the average pressure. So nanatay value for P. Ato na po pangitaon is ang value sa A, which is ang area. So 80 meters times 500 meters equals 4 times 10 to the power of 4 meter square. Since nanatay value for P and value for A, pwede nato ni magamit yung formula. So substitute lang nato ang value for P, value for A, and then ang answer is 1.57 times 10 to the power of 10 newtons. This is the final answer. Example 14.3, page 705 to 707. Calculating force on wheel cylinders, Pascal puts on the brakes. Consider the automobile hydraulic system shown in figure 14.18. Suppose a force of 100 Newton is applied to the brake pedal, which acts on the pedal cylinder acting as a master cylinder through a lever. A force of 500 Newton is exerted on the pedal cylinder. Pressure created on the pedal cylinder is transmitted to the four wheel cylinders. The pedal cylinder has a diameter of 0.500 cm and each wheel cylinder has a diameter of 2.50 cm. Calculate the magnitude of the force F2 created at each of the wheel cylinders. Natay given nga force F1 that is applied sa pedal cylinder. Then ang ato ang cross-sectional area are E1 and E2. Ato ang makalculate from their given diameters. Proceed to solution. We're going to manipulate this by algebraically to get F2 on one side and also substitute the known values. But before that, atong gamiton ang kanisya Pascal's principle applied to hydraulic systems. So atong gipangita is F2. Para mabilin ang F2, multiply both sides by the denominator A2. So cancel lang siya. So mano siya. And then ang ato ang cross-sectional area is E1 and E2. So ato na silang iuban. At the same time, pareha man sa ilahang variables. So mano siya ang ato ang final nga formula. Then substitute the known values, mano sila. Then manipulate, again substitute the F1 which is 500 Newton, manipulate, then we obtain the answer 1.25 times 10 to the power of 4 Newton. This is the magnitude of the force. Example 14.4, page 710, calculating average density. Suppose a 60 kilograms woman floats in fresh water with 97% of her volume submerged when her lungs are full of air. What is her average density? We can find the woman's density by solving this equation. Fraction submerged equals density of the object all over density of the fluid. On the other hand, we can find the density of the object by solving this equation. Density of the object is equals to density of the person is equal to fraction submerged times density of the fluid. So far, so good. Nakabalo na ta sa fraction submerged and density of the water. Pwede na ta mag-calculate for the woman's density. So let's proceed to solution. Density of the object density of the person is equals to 0.970 times ang density of the fluid, substitute, no? Manipulate, and then we obtain the 970 kilograms per cubic meter. This is the average density of the woman. So we observe that the woman's density kanisya is less than to the fluid density, no? Mas gamay siya kaysa fluid density, dako ang fluid density kumparaan ni sa density of the woman. So dako ang ato ang expectation nga maglutaw jud ang bae sa fresh water. Example 14.5, page 714 to 715. Calculating fluid speed through a nozzle. A nozzle with a diameter of 0.500 cm is attached to a garden hose with a radius of 0.900 cm. The flow rate through hose and nozzle is 0.500 liter per second. Calculate the speed of the water A in the hose and B in the nozzle. Magamit nato ang relationship between flow rate and speed in order to find both speeds. We can also use the subscript 1 for the hose and 2 for the nozzle. So let's proceed to the solution. We can solve the flow rate equation for speed and use pi r square 1 para sa cross-sectional area of the hose. And this is the formula. Speed is equals to flow rate all over cross-sectional area equals flow rate all over pi r square 1. Then atong isubstitute the known values and manipulate, and we obtain 1.96 meter per second. This is the speed of the water in the hose. Let's proceed to the second, letter B. We can use the equation of continuity. Ano siya? We're going to solve for speed 2 or V2 and substitute the pi r square for the cross-sectional area yields, and then substitute the known values and we obtain 25.5 meter per second. This is the speed of the water in the nozzle. Example 14.7, page 720 to 721. Calculating pressure. A fire hose nozzle. Fire hoses used in major structural fires have an inside diameter of 6.40 centimeters. Suppose such a Hose carries a flow of 40 liters per second, starting at a gauge pressure of 1.62 times 10 to the power of 6 Newton per meter square. The hose rises up 10 meters along a ladder to a nozzle having an inside diameter of 3 centimeters. What is the pressure of the nozzle? This is the illustration. Solution. We're going to use Bernoulli's equation. P1 plus 1 half times PV square 1 plus PGH1 equals P2 plus 1 half V times V squared 2 plus PGH 2. Since flow rate is equals to E1 and V1, so we solve V1 is equals flow rate all over cross-sectional area. Substitute the known values and we obtain 12.4 meter per second. And then we solve for P2, substitute the known values and we obtain 0.